Okay, in this section, we're going to introduce the idea of an imaginary number, and then from that, we're going to use that to talk about what complex numbers are. So, at some point, we've talked about how if I have something like this, x squared equals negative 25, that if we're solving for x, if we took the square root of this, we end up with a non-real solution, because if I take the square root of negative 5, so far we don't know any number that when we multiply it by itself we get negative 25. So an imaginary number, or I, is going to help us solve this kind of equation. Okay, so real quick, a definition for an imaginary number. So we define I, or I squared, as negative 1. So we define I as the square root of negative 1. So, important thing to remember. When we talk about I, we just mean the square root of negative 1. So there's a lot of ways you might see imaginary numbers written. We have 3a, negative 6a, I think that says 3/5 a, 3i square root of 5. When we just have one term that has the I with it, that's called an imaginary number. We call it a complex number if it's one that has both a real part and an imaginary part. For example, 2 plus 5i. This is my real part, this is the imaginary part. So when we're talking about I, when we're talking about different powers of I, it's cyclical. So we're going to kind of write this here. We're not going to write out a ton of them because it is cyclical, so it follows a pattern. But we said that I is defined as the square root of negative 1, which is I, and I'm going to call that I to the first. I to the second, or I squared, well, if we just said I is the square root of negative 1, well, that's the square root of negative 1 times the square root of negative 1. Well, if we multiply the square root of negative 1 times itself, if we square a square root, we just get that number. So I squared is negative 1. And for what we're going to do today, this is probably the most important one that you'll need, so I'm just going to highlight that there. I cubed, I to the third power, means I squared times I. Well, we just said I squared is negative 1. Negative 1 times I is negative 1i, or negative I. And then the last one, I to the fourth, means I squared times I squared. Well, we said above that I squared is negative 1, so negative 1 times negative 1, which is positive 1. So let me highlight really quick. I to the first is I squared is negative 1, I to the third is negative I to the fourth is 1. What's kind of cool about this is it is cyclical. If we keep going, it's going to follow that pattern forever. So I to the fifth is I to the sixth, negative 1, I to the seventh, negative I to the eighth, 1. And so on and so on. That loop is going to continue over and over and over. So if we have really high powers of I to the 35th, we really don't want to have to write this out 35 times and see what we end up with. So we're going to use the fact that it's cyclical in groups of 4 to help us this. So we're going to divide our exponent by 4 and use the remainder. Alright, so let's see really quick. If I take 35 divided by 4, the 4 goes into 35 8 times. That gives me 32, and we get a remainder of 3. So this is really like I to the third power. If we look above, I to the third power gives me negative I. So I to the 35th is negative I. Alright, if we do this one, my power is 124. If I take that and I divide it by 4, well, I get 31, and I don't have any remainder on this one. So this one means remainder 1, remainder 2, remainder 3. If we have a remainder 4, that means it's divisible by 4, so that really gives us remainder 0. So this is like I to the 4th power, which is 1. So we can use division by 4 to help us work with i's with higher powers. Okay, so now we're going to perform some operations. We're going to do multiplication, division, addition, and subtraction with i's in our problem. The nice thing is when we are adding or subtracting, we just treat the I like any other variable. We're just going to combine like terms. So for example, on 428, we're adding, so I can combine my real parts. 2 plus 4 is 6. I can combine my imaginary parts. 5i and negative 7i is negative 2i. Can't put those together because one's real, one's imaginary. Don't forget with subtraction, we have to distribute the negative, so I get 4 minus 8i minus 3 plus 5i. Now we combine real with real. We get 1. Imaginary with imaginary, minus 3i. And here we've got a little bit of both going on. So I've got 5i minus 3 minus 8i plus negative 4, or minus 4 plus 7i. Let's put the imaginary, imaginary, and imaginary together. When we do 5i minus 8i plus 7i, we get 4i. Negative 3 and negative 4 gives me negative 7. Okay, when we're multiplying, we do it the same way we would if it was any other one. But one thing we have to remember at the end is we don't want to leave I with any exponents on it. So we can use our little chart here to help us if we want to. But really the important one is to remember that I squared is negative 1. If you can remember that one, you can probably work your way to anything else you need. Okay, so on example 431, 3i times 7i, I get 21i squared. Well, we don't want to leave this like this. This really means 21 times negative 1. I squared is negative 1, which gives me negative 21. Okay, on this example, if we distribute, we get 15i squared minus 35i. Again, I squared is negative 1, so we have 15 times negative 1 minus 35i, or negative 15 minus 35i. And as you do these, you really can probably just jump from this step to this step. I just want to show you the middle one so we don't forget where that negative 1 comes from. Okay, 433, we've got to distribute here, twice in fact, so we distribute, 2 times 3 is 6. Then we get plus 10i, distribute, we get minus 12i, and then minus 20i squared. Okay, we can combine these, so I get 6 minus 2i, and then that I squared is really a negative 1, so I have negative 20 times negative 1, or we could just change that to a plus 20. Combine one more time. 6 plus 20 is 26 minus 2i. Alright, and then last one here. If we multiply these first two things, we get 18i squared times 2 minus 3i. And honestly, if I were you, I would go ahead and change this. We know I squared is negative 1. 18 times negative 1 is just negative 18. Now we can distribute again. We get negative 36 plus whatever 18 times 3 is, 54i. If you did not change that I squared right here, you would just multiply like normal and then change it at the end. Alright, and then the last one with multiplication, we have 4 minus 5i to the second power. Don't forget, anytime you see a binomial squared, we write it out like this. 4 minus 5i times 4 minus 5i. Now we distribute. We get 16 minus 20i minus 20i plus 25i squared. Alright, we can combine these two. We get 16 minus 40i, 40i. I squared is really negative 1. 25 times negative 1 is minus 25. If we combine our real parts, we're going to get 16 minus 25 is negative 9 minus 40i. Alright, and then the last operation we're going to do with these is dividing them, sorry. So kind of like we did when we were dividing radicals, is we learned that we never want to leave a radical on the denominator. Well, if we have an I on the denominator, remember that I is really the square root of negative 1. So technically, even though it doesn't look like it, that's a radical. So we want to rationalize the denominators to get rid of i's in the bottom. And the way that we do that is if we have something like this, if we have a monomial, we're going to multiply by I on top and on bottom. Okay, so if we distribute the I on top, we get 7i plus 3i squared, and on bottom we get negative 5i squared. Again, we want to make sure that we don't leave any I squareds here. Remember, I squared is negative 1. So on top we really have 7i plus 3 times negative 1, or minus 3, divided by negative 5 times negative 1, or positive 5. We can't simplify this at all, so we leave it just like it is. And then on the second one, notice we have a binomial in the denominator. This looks familiar. We saw this a couple sections back. So to get rid of a binomial in the bottom, where we have an I or a radical in the denominator, we're going to multiply by the complex conjugate. We've seen the word conjugate before, but we're going to multiply by the complex conjugate. So multiply by complex conjugate. And that's basically the same thing as when we talked about multiplying by the conjugate. It's basically the same thing, but we're going to switch the sign. So in this case, we're going to multiply by 4 minus 8i. All right, let's see what we have on top when we multiply by that. 2 times 4 is 8. 2 times negative 8i is minus 16i. Then we get minus 24i. We get plus 48i squared. On bottom, we distribute. We get 4 times 4 is 16, minus 32i, plus 32i, minus 64i squared. Okay, we're going to combine whatever like terms we have and simplify our I squareds in the process. On top, I can put these two things together. So I'm going to get 8 minus, let's see, that's going to give me 40i. And then right here, 48 times, remember this is negative 1, is going to give me minus 48. On bottom, this and this cancel, and I get 16. Negative 64 times negative 1 is going to give me plus 64. If we simplify again, 8 minus 48 is negative 40 minus 40i divided by 16 plus 64 is 80. We can definitely keep simplifying this. We can divide each of these by 40. And if I divide each of those by 40, I get negative 1 minus 1i, or minus I, divided by 2. And so that's our fully simplified version. All right, the next couple things we're going to do with our complex or imaginary numbers is we are going to simplify some square roots here. But notice we have a negative underneath our square root. So when we simplify like the square root of negative 16, one way we can rewrite this to help us see it a little bit better is 16 times negative 1. So the square root of 16 times negative 1. We can split those up now. The square root of 16 times the square root of negative 1. Well, we know the square root of 16 is 4. We know the square root of negative 1 is I. So we get 4i. In this case, I'm going to rewrite this as the square root of 24 times negative 1. Or we can write this as the square root of 24 times the square root of negative 1 If we simplify the square root of 24 using whichever method you prefer, I'm going to have 2 and 12, 2 and 6, 2 and 3. I can take a 2 out. The square root of negative 1 is I, so on the outside of the radical I really have negative, sorry, not negative, 2I, square root of 6, and that's all we can simplify it. All right, and then example 440, it says when we're simplifying complex radicals, it's important that we take the negative 1 out of the radical as an I before we combine the radicals. So what this means is if I simplify this, the square root of negative 6 is really I square root of 6 times the square root of negative 3 is really I square root of 3. Well, now if we multiply these, I times I is I squared, or negative 1. Square root of 6 times square root of 3 is square root of 18. We can simplify the square root of 18. We get 2 and 9. 3 and 3, we've got a pair of 3's. So I get negative 3 as my coefficient, 2 as my radicand. We get negative 3 square root of 2. Okay, on this last one, it says if there are fractions, we need to make sure to reduce each term by the same number. This is shown in this example. So, for example, really quick, I'm going to take this radical, and I'm going to go ahead and simplify that. In my head, I'm just going to write that as negative 1. I'm going to scoot it. Actually, let me scoot it way over here so it's out of the way. I'm going to write this as negative 1 times 200. And then I'm going to simplify the square root of 200 just knowing that the square root of negative 1 is I. So we're definitely going to take an I to the outside, and then we're going to see what we're left with. So we have 2 and 100, 2 and 50, 2 and 25, 5 and 5. So I'm going to take a pair of 5's out, a pair of 2's out. So I really have a 10 on the outside, and then I only have a 2 left on the inside. So I can rewrite this a little bit as negative 15 minus 10I square root of 2 divided by 20. All right, if we look at our three coefficients here, here, and here, we can divide all of those by 5. So we get negative 3 minus 2I square root of 2 divided by 4. And so that's how we work with imaginary or complex numbers. Really, the key thing you have to remember is that the square root of negative 1 is I, and that I squared is negative 1. If you can remember those two things, you should be set on this.